All right, so law of cosines is another option for solving triangles that are oblique or not right triangles because we can't use SOHCAHTOA. So we will learn today that we are going to use law of cosines for side, 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 and for side, angle, side. All other, I think if you remember it this way, it's a little bit easier. If you have side, 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 and you have side, angle, side, then you use law of cosines. Anything else, you're going to use law of sines. Law of sines is side, side, angle, and angle, angle, side. But if you just remember that these two are law of cosines and anything else is law of sines, I think it's easier to focus on it that way. So these are, the catch to law of cosines is that their equations are more complicated, but there is no ambiguous case here, so it makes it a little bit easier, okay? These two formulas, one can be derived from the other, but they are the same formula. They're just shifted around, solved for something different. The standard form is used to find a side. So if you look, there's a pattern, and if you just remember your pattern, it will make life easier. If I'm trying to solve for a side, so this case would be if I had side, angle, side. Then a squared equals b squared plus c squared minus 2bc times the cosine of a. B squared would equal a squared plus c squared minus 2ac cosine b. And c squared would equal a squared plus b squared minus 2ab cosine c. So the pattern goes the sum of the squares of the two sides you are given minus 2 times the product of those sides times the cosine of the angle you are given. And then your last step here is going to be to square root both sides because you want to get just a. So a lot of times I will even just write this as a equals the square root of b squared plus c squared minus 2bc cosine a. Okay, you can also write it like that because that's going to be your last step. And we would normally say that's plus or minus the square root, but these are side lengths, so they will never be negative, so we'd only keep the positive.
Why are we putting it there as square root?
Because this is a squared, and at the end I want a. So the last thing you're going to do is square root both sides. Then you've got your alternate form, and really this is just solved for this part of my equation. I would have taken a squared, subtracted b squared, subtracted c squared, divided by negative 2bc, and I would have gotten cosine a. They just did it for you already. Cosine a, so this is when you're given all three side lengths. You have to have all three sides. Cosine of a would be the other two sides sum. So b squared plus c squared minus the side that matches the letter you have, minus a squared over 2bc. And then cosine of b is a squared plus c squared minus b squared over 2ac. And cosine of c is a squared plus b squared minus c squared over 2ab. So my advice to you is every time you go to start a problem, you write out that formula so that you start to remember it. If you do this with homework tonight and again on your quiz review tomorrow, you'll have written it like 7 times. By Friday, you should have remembered it, okay? If you look at these and you notice, like we talked about it with side, angle, side, and side, 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 both of these will have one of each letter. So you will either get A, B, C all lowercase, or you will get A and B lowercase and then the capital C because it's the angle. Or you'll get capital A because it's the angle and then lowercase b, c, but you will have one of each angle. So I think these are easier to spot. And then if you don't have that information, then you're going to use law of sines. No, you had your hand up.
The alternate form, if it's SS, why are we finding these?
Because you're going to get given all three sides, and you have to find two angles and then subtract for the last one, you'll subtract it from 180. All right, so we're going to start with a side angle side. On a side angle side, we're going to find the missing side using law of cosines. And then here's the catch with this, and this is, I'm going to suggest that you do something a little bit different. But if the angle that you were originally given is obtuse, and then you find that first side, then you can actually switch to law of sines. And the order won't matter, okay? If the angle you were already given is obtuse. So if A is given to you, let's say, angle A, and it is obtuse, then I can find whatever side I'm missing, And then I can use that I can use anything, because I'll have two letters, and set up law of sines. If not, then the order in which you find things matters. Because if it is not obtuse, then you can invent a second triangle that doesn't actually exist. So instead of doing the switch to law of sines, I would strongly recommend you keep doing law of cosines, and then the order does not matter. So again, my advice is, because even though you can switch to law of sines, if you forget and it wasn't obtuse to begin with, then you have to stick to law of cosines. My advice is just stick to law of cosines. And then you'll find the second angle, and then you'll subtract the first two from 180. So we'll walk through that process, but it's going to start with something like this. It says use the law of cosines to solve the triangle. Note your quiz is not going to say law of cosines. It's just going to say solve the triangle. You're going to look at this information. You're going to say, I have an angle and two sides, and it's one of each letter. So that side angle side. If you want the visual on it, then draw it out. 39 degrees. B is 21. C is 42. That is two sides and the angle where they meet, which tells you it's side angle side, and that tells you you're going to use law of cosines. So the very first thing I have to find with law of cosines is the third side. So a squared equals b squared plus c squared minus 2bc cosine a. B squared is 21, so 21 squared, plus c squared is 42, minus 2 times b, which is 21, times c, which is 42, times the cosine of 39. And then you could literally type that whole thing in your calculator. Order of operations will put it how it's supposed to be. And you could even put it under a square root now. You don't even have to do that in 2 steps. But if you wanted to just do 21 squared plus 42 squared minus 2 times 21 times 42 times cosine 39. This is what a squared equals. So a squared would be 834.114524. And my last step here is to square root. So I'm going to square root without rounding that answer. And I get a is 28.88. We're going to keep both those decimals. You with me so far? So when you're given side angle side, the first thing you have to find is the other side. Because to do any of the angle formulas for law of cosines, you need all 3 sides. Okay, so now look what we have. We have one complete ratio, right? Which means technically we should be able to switch to law of sines here. I have A and angle A, right? So then I could have switched to law of sines. But what was originally given to me is not an obtuse angle, so it is not safe to do that. If the original angle was given to you as obtuse, then it's safe to do that. But if it is not, you actually could invent a second triangle that doesn't actually exist. So you have to be really careful here, okay? My advice, just stick to law of cosines. When you start law of cosines, just stick to law of cosines. So then I'm going to find one of the angles that I'm missing. So let's say I want to find angle B. The cosine of B equals the other 2 letters, so a squared plus c squared minus the letter that matches over 2 times those first 2 letters. So a squared is 28.88. It's a rounded number, but you cannot avoid using it. C squared is 42. And b squared would be 21 over 2 times 28.88 times 42. Now here's the catch on your calculator. You have to put parentheses to group your numerator and your denominator, or you can use the fraction bar. If you want to use the fraction bar, you don't have to worry about your parentheses. But if you do not, and you don't put those parentheses, the very first thing order of operations says to do is take 21 squared and divide it by 2. And that's going to give you a wrong answer. It actually will give you something that's bigger than 1, and then it won't let you find the angle. It'll give you an error. So I'm saying either put parentheses around 28.88 squared plus 42 squared minus 21 squared, close your parentheses, divided by, open your parentheses, 2 times 28.88 times 42. So my calculator looks like that right now. This is what I have typed in. It's off the screen. But you have to make sure you put them in parentheses. Or use your fraction. Yeah, no cosine though. You did something. And then that's the cosine of the angle, which means the last thing we have to do is cosine negative 1 it. And you should get 27.23 degrees. So I've got side A, I've got angle B. I was missing A. I was missing angle B. And I was missing angle C. For that last angle, all I have to do is subtract the other two from 180. So 180 minus 39 minus 27.23. And you get 113.77.
Why do you know, like, is it the SAS, is that how you know it's cosine?
Yeah. Side angle side and side side side. Like side 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 should be the most obvious because it's all three sides. You can't do anything with law of sines with that. Even if you look at this in the beginning, you don't have two of the same letter. And there's no way to find it. Like you can't mess it up because you don't have the right information. Does that make sense? Yeah. You can't use the other formula. It's not like one formula is going to work and the other one's wrong. It literally cannot work. Was there another question over here? We're good? Yeah. Okay.
I said we're good.
Okay. The other thing I would say is if I had extra time, I could come back and I could actually do the cosine of C, like use that formula to make sure that I get that 113.77. And it might be a 10th off, depending on how accurate we were on our rounding on the first thing. But if not, it should be, even if it's only a 10th off, it should be, I mean, not a 10th, a 100th maybe. It should be pretty close, okay? So if you had extra time, you could go back and check it the other way. Questions on that one? Okay, then comes side, side, side. Side, side, side means you're going to have one of each lowercase letter, A, B, and C. I think to me that's the most obvious one to spot. And again, you kind of have a choice here, but I'm going to strongly recommend that you just stick with law of cosines the whole time. If you use law of cosines to start and you find one of the angles, and then you switch to law of sines, then you could do the same thing you did the first time and accidentally pick something that could invent a second triangle. The way to avoid that is two ways. One is always pick the largest angle first, which would be opposite the largest side, or the longest side. So if my longest side is A, I can find angle A first, and then I can switch to law of sines. The other option is use law of cosines the whole time, and then order won't matter, which is what I would recommend. When it's law of cosines, stick to law of cosines. And then you won't invent this second triangle that doesn't actually exist. All right, example 2. So use law of cosines to solve the triangle, and then again, round to 2 decimal places. I would say this is when I don't draw a triangle. It should be pretty obvious that there's 3 letters there, right? 3 letters, 3 sides, 3 lowercase letters, 3 sides. If I wanted to switch from law of cosines to law of sines, then I'd have to start with which angle? The largest, which would be which one in this case? C. Okay, so if you wanted to switch, you could. But if you want to switch, you have to start with C. If you're not going to switch, it doesn't matter. So I always start with the largest just because if you're a person that wants to switch, I would just get into that pattern. So I'm going to do cosine of C equals A squared plus B squared minus C squared over 2AB. Write it out every time until it becomes second nature. So cosine negative 1 is what I'm going to type in my calculator of a squared, or 11 squared, plus b squared, 14 squared, minus 20 squared over 2 times 11 times 14. And if you type it in, again, making sure you're either in the fraction format or you're putting your parentheses, then you can do that all in one step. There's a shortcut for your fraction button. I don't know if you know this. If you hit alpha, y equals, so if you hit the green button and you hit y equals, number 1 gives you that fraction bar. Okay, so this was angle C. Okay, that's what my calculator looked like. So I got angle C is 105.63 degrees.
I got my angle C was 0.64.
All right, then we're going to go to B. Or A, again, it doesn't matter. So if I do B,
I guess you guys are wrong. That's right.
cosine -1 of A squared plus C squared minus B squared over 2AC. So cosine -1 of 11 squared plus 20 squared minus 14 squared over 2, 11, 20.
That's going to be 42.
So now angle B, 42.38 degrees. And then to find A, I just subtract the other two from 180. So 180 minus 105.63 minus 42.38. And if I had extra time, only if you have extra time, would I recommend this. But you could then go back and find that last one using your law of cosines and check to see if it's the same. Again, it might be a little bit off because of the rounding, but it should be pretty close. Yep. All right, this one, like I said, I think that the word problems for sine and cosine, for cosine are a little bit easier because they're a little bit more obvious what you have. It's either going to be side angle side or it's going to be all three sides. So this one says find theta between two paces for both the carnivore and the herbivore. So on the left-hand side, it already gives you the diagram, okay? This would be side angle side because I have the two, or no, this would be side 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 because I have all three sides. So if I want to find the angle here, I could label this A, B, C, it doesn't matter, okay? I could also just call it X because all I need to do is the side opposite is the letter that matches. So I'm going to do these two sides first and subtract this one from it. So if this is A, this is B, and this is C, then the cosine of A equals B squared plus C squared minus A squared over 2BC. So I'm going to do cosine -1 of 2.9 squared plus 3 squared minus 5.78 squared. Put it over 2 times 2.9 times 3. And again, let your calculator do that whole step. So your angle there is 156.85 degrees. That's the angle of the carnivore. Then the angle of the herbivore would be, again, the two that are next to it. So 3.6 squared plus 3.2 squared minus 5.2 squared over 2 times 3.6 times 3.2. And then we're going to cosine -1 that whole thing. .6 squared plus 3.2 squared minus 5.2 squared over 2 times 3.6 times 3.2. And I get that theta is 99.59 degrees. Questions on that one? All right, example 4 says, if you are on island B, what bearing would you navigate to go to island C? So we're going backwards from our bearings yesterday. Like yesterday, we talked about a bearing when we built the triangle. Now you have the triangle and you need to find the bearing. So if I'm on B and I need to get to C, I'm going in this direction and then I'm turning and going this direction, right? So what's the north, south, east, west part of my bearing? Am I going north or south? from B to C? North. And then from B to C, am I going east or west? West. So now I got to find the angle. And I need the angle on the outside of that triangle, but obviously I have to use the angle on the inside to get to it. So I'm going to use my law of cosines to find angle B, and then I'm going to subtract it from 90 degrees to get the one on the outside. So angle B would be cosine of B would equal, this would be B, this would be C, this would be A. So A squared plus C squared minus B squared over 2AB. And I'm going to cosine negative 1 that whole thing. 2AC. Yeah, sorry. I said C but wrote B. I mean, I said B but wrote C. Second cosine. (22 squared plus 23 squared minus 16 squared over 2 times 22 times 23. 41 degrees is angle B, 41.58. But that's what's inside my triangle. So to get what's on the outside, I'm going to do what?
Minus 90.
Good. Subtract that from 90. And I get 48.42 degrees. Okay. Last up for what's going to get covered on your quiz is the second area formula. This is called Heron's area formula, okay? Cosine is not in this formula at all. It is just put in this section, okay? Because it is side, side, side. Side, side, side is the information that would be given to you. You'll have the lengths of all three sides. And then we use this formula to find the area. It is the square root of S times S minus A times S minus B times S minus C. And the first thing you have to do is find S. To find S, we add the three sides and divide by 2. So almost the average, but not quite because we're dividing by 2. Super important here is that we do not round S. So if S has 3 decimal places, you keep all 3 decimal places. If S has 4 decimal places, which I think is most can have, then you keep all 4. You're going to round the answer at the end, obviously, for your area, but you do not round the S. All right, so example 2, find the area. I don't know, that's not example 2. I don't even know what number we're on now. 5, yeah, find the area of the triangle with the given side lengths. So I have all 3 sides. I'm going to find S first. 5 plus 7 plus 10 over 2. It is 22 over 2, which is 11. Nice round number this time. So then the area is equal to the square root of 11 times 11 minus 5 times 11 minus 7 times 11 minus 10. And you can simplify out your parentheses if you want, but you might as well just let your calculator do all that work for you. Type that whole thing in. 11 minus 15, or minus 5, 11 minus 7, 11 minus 10. And my area is 16.248. So we're going to say 25. If there was a unit, it'd be unit squared because it is area. This time it doesn't matter. They don't give you the unit. All right, so your S was 3.125. And then you get the square root, 3.125. 3.125 minus 3.05, 3.125 minus 0.75, and 3.125 minus 2.45. Sometimes it takes longer to write that out than it does to type it in your calculator. So on your quiz, you have to give me S. As long as you give me S and then you give me your answer, you're fine. But if you give me the wrong answer and nothing to back it up, guess what happens, folks?
0 points.
All the points are gone. That's devastating, okay? So you got to at least give me what your S is, because if maybe you rounded or you did something wrong, I can give you partial credit. But if you don't, no partial credit. 0.05, 3.125. And we just said this, but S has to be bigger than each individual side. But my answer at the end, the area can always be smaller than any of your side lengths, which in this case it is. It's 0.6129. So 0.61 units squared. Don't panic if your area is smaller than your side lengths. That can happen. Yep.
It'll tell us what to round to?
Yes, I think area I did nearest 10th, but yeah, it will tell you. Each individual one tells you what to do. All right, so let's go to the word problems from yesterday's assignment. Specifically 48. It said a flagpole is at a right angle to the horizontal, is located on a slope that makes an angle of 12 degrees with the horizontal. So you're talking about something that's like a sloped ground. If I had drawn the horizontal and then I drew my flagpole, right? I don't care which way the flag goes, but the flagpole, then it says that there's the ground has a slope, and it says the flagpole shadow is going up the slope. So my brain draws a slope to the right, but you don't have to. Like it could have gone the other direction. It could have gone to the left. And that slope means that above my horizon, it's 12 degrees. So this little sliver in there is 12 degrees. And that let's say the sun's over here. I don't know why it's a green sun, but it's a green sun. The sun's over there. That means that this back here would be my shadow. And it says the shadow is 16 meters long. But then it says the angle of elevation from the tip of the shadow to the sun is 20, which means angle of elevation goes from level, which means I kind of have to draw an imaginary level here, up to the sun. So this in here is 20 degrees.
Is that gonna be on the quiz?
No, the ones on the quiz are not this complicated. Okay. Then it says, draw the triangle to represent the situation. Show the known quantities on the triangle and use a variable to indicate the height of the flagpole. So if I know that this little sliver in here is 20, this obviously has to be a right angle. That leaves 78 degrees inside the triangle for that corner. And then the corner on the right, I have to actually take that 20 and what would be below this 20, which is an alternate interior angle with the 12, which means this is also 12. So I feel like this is a great standardized test question because it brings back in your alternate interior angles, just in case you missed those. Okay, things like slope with a horizontal, all that angle of elevation. Standardized tests love this crap. So that's 32. Now could you solve this?
Oh, yeah.
Okay, we have angle, side angle, which means not law of sines. Like, I mean, not law of cosines. Think about this. They're going to get looped together. Angle, side angle would result in law of sines because I can from here find this angle up here by doing 180 minus 78 minus 32, and I'd get 70 degrees. And then I'm looking for, what are you looking for? The height of the flagpole. So here's my complete ratio, 16 over the sine of 70 equals x over the sine of 32. And then 16 sine 32 divided by sine 70. X is 9.02 feet. Meters. It's okay. 50 gives you the picture and it's got bearings, okay? It actually already had the bearings drawn on there, but I would say make sure you would understand how to get like from the gazebo to the dock. So gazebo to the dock was south 41 degrees west, which is why that's there. From a tree 100 meters from the gazebo, there's that measurement. The bearings from the gazebo to the dock. No, I just did that one. Sorry. From the, oh no, gazebo. And the tree to the dock are the southeast 28 degrees. So from the tree to the gazebo was 74, and from the tree to the dock was 28. So if I want to find the distance from the gazebo to the dock, I'm looking at this side. In order to find this angle, I'd have to do 74 minus 28. So this is 46 degrees. And then that's the ratio of that side. It would be x over the sine of 46 degrees. Now I have to find this angle here, okay, because this is the only measurement you have. So we go back to every north-south line would be parallel to every other north-south line. And if this is a transversal, then this angle in here, this whole angle here, would correspond to this whole angle here, which means that's 74 degrees. And what does all three of these angles have to add up to? 180. So I do 180 minus 41 minus 74, and then you get 65 degrees in here. Now subtract the 46 and the 65 from 180, and you get 69 degrees for the dock. So 100 over the sine of 69. And then cross multiply, divide. 100 sine 46 divided by sine 69. And x is 77.05 and meters. I would say sometimes the photograph overcomplicate. Like I feel like if they give you a picture, they make it a little bit harder of information. If they don't give you a picture, it's a little bit easier. You are not getting pictures on your quiz. Okay. I actually think the makeup has a picture, but the regulars don't. I ran out of